Hello, my name is Birring and today I will be covering the magnetic particle testing method. And in this method I will be covering the different techniques of doing magnetic particle testing, which will be the wet fluorescent, the dry powder and the wet visible MT. But before we start discussing those different techniques of doing magnetic particle testing, I want to simplify the whole subject of this MT method. So for simplicity, you have to remember that magnetic particle method has two very important parts. One is how to magnetize the material, and then the second one is how to detect the discontinuities. And what we call that as the magnetization methods. So there are different ways of magnetizing the material to be testing, and that's called the magnetization methods, and I'll go through that. I'll show you the equipment. And then the second part is the magnetic media. Magnetic media would include the dry powder, the wet visible particles, and the wet fluorescent particles. So going back to summarize, the magnetization methods and the magnetic media. And then the third item is the accessories, which is going to be the black light, the Gauss meter, the pi gauge, the shims, and the light meter, and the 10-pound weight. So these are the accessories which are used for the magnetic particle testing. So let's go one by one and let's go to the magnetizing methods. So magnetizing methods, here the first one, let me come on this side. This is the AC yoke. This is AC yoke, and that's very commonly used for the magnetic particle testing in the field. Then this one is another yoke, and this one, as you can see, is a bigger yoke than the AC yoke. This is basically a DC yoke, and DC yokes are for a little bit higher depth of penetration, and but they are heavier to use, so they are really not commonly used in the field. The most common yoke used in the field is the AC yoke. Then the other two magnetization methods are this is a coil, and this is a small version of a coil for my training, but then when you are in the fab shops, you'll see bigger versions of the coil. This is for longitudinal magnetism. And then this is a current source which is used for the circular magnetization, in which we pass the current through the part, or we use what's called a circular conductor, in which a conductor is passed through a hollow part. So that produces current. The one I have is only for training, and this one only goes up to 1000 amps, but the ones which are used in the shops will either go up to 5000 amps or 10,000 amps, and they are mobile units. So we covered these, and then this is the magnetization methods. Then we go to the magnetic media. The magnetic media are dry powder. This one is dry powder, which we put it in this little bottle here, and to sprinkle the dry powder. And then we use the wet visible. So in order to use the wet visible, this one has black particles. In order to use that, we will need a white contrast paint, which is this one. So a white contrast paint is applied on the surface before we use the wet visible particles. So these two go together, and that's one magnetic media. And then the third one is the wet fluorescent. So the wet fluorescent is the most sensitive magnetic particle technique. So in that case, we use the fluorescent particles. In order to use that, and in order to detect the discontinuities, we have to use a black light, which is here. So that produces a UV light. So you will need this one, and then you will need a light meter, which is this one. And this light meter actually can measure both the visible light and the UV light. So you turn it on, and it will give you a reading of the black visible light, and it will give you reading of the, so it's telling me it's only 408 lux visible light, and there is no UV light. And again, this is a 10-pound weight to check the AC yoke, and for the DC yoke we have to use a 40-pound weight. So I think I covered everything except this is a pi gauge to check the magnetic field adequacy. This is another way of checking magnetic field adequacy. This is a shim, and the shim has basically 3 lines, and you should see all the 3 lines. They go straight. So I'll give you a demonstration. This is the Gauss meter, because in some specs they want you to have magnetization level of about 30 Gauss or 40 Gauss. So in that case we use a Gauss meter which is like this, and that goes up to 60 Gauss, this one. And then this is the last one. This is to check the residual field, and that's only used if you're doing inspection of rotating parts, and they will have a specification that after you're done with MT, and that's only for rotating parts, not for structural, that the residual magnetic field should be less than 3 Gauss or whatever the spec says. So now I will give you a demonstration, quick demonstration for all the methods. So first demonstration will be the dry powder method using the AC yoke. So the magnetization method is the AC yoke, and the magnetic media is the dry powder. So in this case you need a visible light level of 1000 lux. And so first thing we have to do is check the 10 pound. So all you do is you put it here. So according to the code, this should be checked daily before doing the magnetic particle testing. Now we go here, these are some samples. And the important point is that if you want to use the pi gauge, just to give you a demonstration of the pi gauge, I'll put it here, and then you can see the lines on the pi gauge. And so you can see the line here, and the line which is transverse to the magnetic field will show up. The one which is parallel to the magnetic field will not show up. So what that means is that, so you can see that. So in order to see the discontinuities in all the directions, we should not be limited to doing the inspection like this. So what we need is we have to do the inspection in two directions which are 90 degrees to each other, and that applies to all the MT techniques, is that plus minus 90 degrees, whether you're doing shafts and stuff like that. So what it means is that I have to do a test like this and a test like this. So two 90-degree directions, and all you do is the MT is very simple. With the dry powder, you put it here and you just sprinkle lightly sprinkle. So it should be lightly sprinkled, and then you can use this one to remove extra particles and see if you can see any indications. So this one and then this one. Okay, there's a discontinuity right here. It's dark here. So that's how you would do it. So it's here. So anyway, that's a quick demonstration of the dry powder method with the AC yoke. So the next one will be the longitudinal magnetism, and the magnetic media I will use is the wet fluorescent particles. Okay, so we are going to do wet fluorescent particle testing, and the method is longitudinal magnetism using the coils. So first step is to check the UV light level. It should be more than 1000 microwatt per centimeter square, and right now you can see that when I put it here, it's showing more than 3000, more than 4000. So that light is really good. So we are good. There are two sensors on this UV light meter. The top one is the UV and the bottom one is the visible light, and you get two readings for each of the two sensors. So we are done with that. Now we will start doing the test, and the compressor shaft we are going to do it using longitudinal magnetism, which means the current goes like this in the coil and the magnetic field will be longitudinal. What that means is that you should be seeing the transverse indications. So to see the transverse indications, I zap it with the magnetic field, and I'm going to turn it on, and when I put you can see the three lines now. Let me demonstrate this method, longitudinal magnetism using the fluorescent particles. So here is the coil, and the current goes in this direction, so it means that the magnetic field will be longitudinal going in this direction, which means that it will be sensitive to transverse cracks, and we will check it with the shim. So all you need is apply the magnetic field, and I'm applying it, and then you spray the particles, and you spray them here just to check the adequacy magnetic field, and then you check it with the black light and you see it really good. So you can see all the 3 lines. That means we have sufficient magnetic field for this test. Again, this will only find the discontinuities which are transverse to the shaft or at plus minus 45 degrees, but it will not find the discontinuities which are parallel to the length of the axial direction of the shaft. So for that you will need what's called circular magnetism. In the circular magnetism, what you would do is you would actually have 2 copper pads here, and then you pass the current through this shaft, maybe 600-700 amps or 800 amps current, and that will produce a circular magnetic field, and then you can put the shim in this direction and find axial discontinuities. So again, for each magnetic particle method, you have to apply the magnetic field in 2 directions, plus minus 90 degrees. So we covered that one, and now I am going to cover the one more, which is the central conductor method. So this method or this technique is the central conductor, in which we pass the current through the part which is like a hole in it. So this one I've taken a tube and I'm going to pass the current through it, and it's connected to a current source. Like I said, this is a small one. It only goes up to maybe 1000 amps if I'm lucky. And so we will do wet fluorescent method on this one, and in this case which means that the current goes this direction, and using the right hand rule the magnetic field will go in the circular direction, so which means that you would be able to find discontinuities which are axial in the axial direction. So let's do that. And I already put a shim here, and this is the fluorescent particles, and we already checked the black light and it's ready here, and the current source is ready to go. Okay, here is a demonstration of the central conductor. I have a boiler tube here for demonstration, and I put the shims here with those 3 lines and magnetic fields, and then I will press the button to apply the current, and hopefully we should start seeing the lines. And there we go, we can see the lines there, and I'll angulate the black light so you can see it a little bit better. So that's you can see all the 3 lines on the shim, and if you pass more current they will be even more visible. So this is the last technique of this video, and in this portion I will be giving a demonstration of the wet visible particle method using the yoke. So the magnetization method is the AC yoke, and the magnetic media are the wet visible particles. So they are not dry, they are wet visible. And only one additional step what we do in this method is that we add what's called the white contrast paint to improve the contrast of the discontinuities. And the reason is that the particles, if they're black color particles and the background of the steel is also dark gray, it's kind of difficult to see them. So to enhance the discontinuities, we do a spray, white contrast paint spray. And again, this is also available from the magnetic particle suppliers. We don't use the paint from the hardware store. So this is a special paint with a very thin layer. So what you do is that you spray light spray of the white contrast paint like that. So just like that. So just let's say like that. Here is the AC yoke. Do a 10-pound check, and then I take the yoke. And again, this has to be done in 2 directions, but for the demonstration I will just show you one direction. And here we go. This is the wet visible particles, and the paint has dried. It just takes a few seconds to dry. And then what you do is you just apply the magnetic field and then apply the particles. So here we go. So if there's any discontinuity, it would actually show up. And on the weld here, and let's do this one. And here we go, this one here. Okay, here there is one discontinuity here, and it's right there. You can see that. So can you do a close-up? Mm-hmm. The toe crack. It shows up really good with the wet visible particles. So thanks a lot, and in this video I just wanted to cover all the methods in one video instead of making separate videos which were made many years ago. So here you can actually cover the whole subject of magnetic particle testing methods and techniques. And thank you very much, and see you again